First one is the product rule, i.e. we are multiplying. So if you're multiplying two of the same bases, so we have an A and an A, you add your exponents. So that will be, keep the base. So you write your A down and you add the exponents. Okay. Yo, ma'am, can we see the top 10? We already did, Moremi. You must come on time if you want to see the top 10. Come on. Come on. I will forgive you today, but you need to come on time next time, yeah? There we go. There we have your top 10. There we go. That's why Moremi wanted to see, because Bukamuso is number 1. We see you, Bukamuso. Well done. Major shout out. Okay? But please come on time next time and you'll be able to see this. Otherwise, I can't keep scrolling back and forth. Okay, major shout out once again. Cool. Let's go back to our laws of exponents. And I suggest we listen. We want to get these correct. Okay, the second law. What does the second law say? Someone unmute, speak to me. You guys are distracted. Rather speak to me and tell me what the second law says. Oh, Katu's hand is up. Do you have a question? I feel like I missed Katu's hand. Hello. You may unmute.
Hello.
Hello.
I don't have it. I wanted to ask if when are we gonna do percentages?
When are we gonna do percentages?
Yes.
We already did. I'm pretty sure they already did percentages, perhaps, but not in this term. Okay, we're doing exponents now and then number patterns. So percentages are not right now part of this term syllabus. But you can go to the website and you can check out the videos that are uploaded under the grade. Okay.
Okay.
So who's gonna tell me what these laws say? Someone? Anyone? Raise your hand and let's talk about these laws. Tell me what each of them say. Otherwise, I feel like I'm talking to myself, which is unhealthy. Unhealthy. Hi, Ashley. Misha dozed off last week. Yo, what a difficult. Guys, no one. So you guys don't remember the laws of exponents. That is a little bit concerning. More than a little bit, but it's fine. Okay. Yes, that's what I'm asking. I'm asking you what these laws say. So the quotient law says when you are dividing. So in the product law, we were multiplying, right? Now we are dividing two of the same base. So you keep the base, as we say in class, and you subtract the exponent. That was a terrible color choice. But you subtract the exponents. So if you have a to the exponent of x divided by a to the exponent of y, then you will keep the base, which is a in this case, and you will subtract our exponents. Okay, now let me choose a better color. Power rule. Okay, this is on the one that says we have a power to a power. So we have two exponents. So you have a whole a to the exponent of x in brackets or raised to another power, which is y. Okay, in that case, what do we do to the exponents, guys? Tell me in the chat. Since we don't want to unmute and talk to me, it's fine. Remind me in the chat, what do we do if you have power to a power? What happens to the exponents? Novoya raised up her hand, I think. Yes. Novoya?
Ma'am, you're going to multiply the exponents and keep the base the same.
Thank you very much. So we keep the base and we multiply the exponents. Novoya, don't run away. The one that says 0 exponent. What does that mean? Anything to the exponent of 0 is how much?
1.
Is 1. So the answer will be 1. But you have to pay attention to where the 0 is. And then what's happening there by the last one, Novoyo?
Ma'am, it's if the exponent is a negative, you're going to put you're going to make the exponent you're going to make the exponent the positive, and then you're going to write it over 1.
Thank you. So you use the reciprocal. Thank you, Novoyo. You were listening. I like it. Keep raising your hand, okay?
No.
Oh, Chichi wanted to do the last one. I just saw your message. I'm sorry. I'm sorry, guys. Okay, so I see you guys are answering as well in the chat. Thank you very much. Zintle has her hand up. Hello, Zintle. Hi, Zintle.
Hello.
There we go. Do you have a question?
Yes, can I please ask, did you guys do financial math?
Guys, if you want to know if we did anything, just go to the lessons page under grade 9. You know, after you press grade 9, it usually has the upcoming lessons, and at the bottom it has the recordings of the past lessons. I need you to go check there, okay?
Okay, thank you.
Thank you. Okay, guys, remember, let's keep the questions and the chat related to the lessons. So what we're doing today is exponential equations. Okay. Indication in the chat. Who has seen exponential equations before? Who remembers them? Who has worked with them? Let's hear where we all stand with exponential equations. There we go. Evila has worked with exponential equations. I'm actually, okay, I asked like 5 different questions. So if you've heard about it and you like them or you know of them, give me a thumbs up. If you've never heard about them and I've just lost, give me a thumbs down. Just want to see an indication of what you guys remember, what you guys know, so that I know how this is going to go. Thumbs up. Ooh, Evila likes them. Okay, Amahle also says thumbs up. KG, thumbs up, guys. There's about 68 of you in here, and I'm not moving on until I get more responses. There we go. Okay, KG says thumbs up. Fundiswa, it's okay. Welcome. Yeah, that's a thumbs up. OM says 2, not sure what that means. Butu says thumbs up. Mpo says thumbs up. Maria says never heard of it. Novuyo says thumbs down. Okay. Okay. It feels like most of us have heard about it. Okay, it's okay. Wangi, welcome. Welcome. You are new. It's nice to have you. Sbangogu says thumbs down. Okay. It's okay. It's okay, guys. If you've never heard about them, we are going to fix that right now. So let's talk about this. We're working with equations, right? Okay, Katleho has a hand up. Katleho. Katleho. Oh, you're already telling me the answer. I see you, Owani. You guys are decades ahead. Okay, Katleho, when you are ready, you can unmute. I'm moving on with the lesson. So first things first is we're working with equation, i.e. there's an equal sign. There we go. Hi, Katleho. Okay, Katleho, there's a lot of noise and background noise on your side. So please type your question in the chat. Okay, if I don't see it, Melissa will tell me about it and I will address it. Okay, let's talk about example 1. First things first is we're working with an equation. What do equations mean? They mean the left-hand side is equal to the right-hand side. So equation are essentially a statement, right? Please mute. There's a lot of background noise. There we go. Okay. Yes, guys, I know, but I have to explain. Okay, you guys have to be patient because not everyone in here has heard about these. Okay, so equations mean the left-hand side is equal to the right-hand side. So now in this case, we have our x in the exponent. So we are solving for x. So what this equation is saying to us is 2 to the power of something that we don't know yet. So 2 to the exponent of something is equal to 4. Okay, so we know that 2 is the answer, but there are steps to follow, okay? If your teacher's like me, she will penalize you if you don't put in steps there. So we know 2 to the exponent of x is equal to 4. But but we can rewrite 4 to have the same base as what's on the left-hand side. Okay, so if we rewrite 4 to the power to the base of 2, as Nelly was so nicely said for us in the chat, it's going to have an exponent of 2. Okay, do we all agree that 2 squared is the same as 4? I hope we all know that and that we agree. So now that we have that, do we see that we have these same bases at the bottom? Everyone who said they've never seen these before or they don't like them, thumbs down. Now we have the same bases, right? This pen is too thick. Let me reduce it. There we go. So now that we have the same basis, if 2 to the exponent of something is equal to 2 to the exponent of 2, then x, therefore, x has to be equal to 2. Otherwise, there is no other way that this would work other than x being exactly 2. Okay, so the people who said they've never seen this before, are we sort of understanding how these work? So A, we want to have the same bases on the left and the right-hand side. Then once we have that, we can equate the exponents. Are we understanding? Give me a thumbs up. I understand, ma'am. Good, beautiful. Okay, all the people who said they've never seen this before are now on board. On board. Okay, let's do a couple more. Lee says thumbs up. Fundiswa, Katu. Wonderful. Okay, now, all those people, same people, tell me what base do we want to be working with here? Bridget says thumbs down. Bridget, please raise your hand so we can talk about it here. Best way we can do this, Bridget, is talking to each other. Please raise your hand so that I can have a nice chat with you about it. So we can do the next one together and we make sure that you understand. Okay, Bridget is not raising Bridget's hand. It's okay, Bridget, if you're shy. I've asked you to unmute, so you can unmute if you want. Bridget says, what was the question? Ma'am, can you explain? Is Bridget's hand up? No, it's Eddie. Bridget's question was, ma'am, can you explain how you got 2? Bridget, we changed 4 into a number that is to the base of 2. Okay, so we want both sides to have the same bases. Right? Now, do you agree, Bridget, that 4 can be written as 2 squared? Because 2 squared is the same as 2 times 2, which is 4. Do you agree, Bridget, that you can rewrite 4 as 2 squared? Guys, I'm going to need you guys to cooperate and not jump the gun. Okay? I'm explaining for the people who do not know this. Be considerate. Sometimes you will not find topics that you have seen. And would you like it if everyone was impatient and just posting answers? No. Okay? We are helping the people who've not seen this before. So I got 2 from saying 4 can be written as 2 squared. Okay. Now, Bridget, if 2 to the exponent of x, remember we use an x because we don't know what's there. If 2 to the exponent of x, whatever that could be, is the same as 2 to the exponent of 2, exactly, Bridget, then x has to be equal to 2. Do you see that? That is the only way that our equation will work out. Remember, equations are saying to you the left-hand side is equal to the right-hand side. Okay, Bridget, let me know if you feel better. There we go. Wonderful. And if we can have more patient people in the chat, we'll have more people who understand. We're not rushed. Now, guys, patience. Remember, we respect each other and listen to each other's questions. Right now, we're not practicing that. Okay, now we are on B. Which base do we want? Ivile says 3. Okay, I see people's hands up. I don't know if those are questions or those are, I want to help you solve this, ma'am. Let's see, Rea Mokhetswe. I don't remember ever hearing your voice. Hello, Rea Mokhetswe.
Ma'am, no, ma'am, I understand that. I was struggling with A.
Okay, so are you fine now?
Yes, thank you, ma'am.
There we go. You're welcome. Guys, answer my question. Eh? My question was, what base do we want? We want 3. So since we have a 3 on the side, we want to have the same base on the right-hand side. So we're going to rewrite the left-hand side because it already has the desired base. Equals. Yes, Eddie. There we go. Eddie. I know you're going to help me solve this, right?
Yes, I'm going to help them.
There we go. So if you want a base of 3, it's going to be?
It's going to be, okay, so I kind of just want to see the answer, ma'am.
We need to go step by step, guys. You cannot skip
Yes.
steps. Do you get full marks when you skip steps at school? I would not give you those marks. So it's going to be 3 to the exponent of what?
Of 3.
3. Thank you. Now that we have the same base, what can we do? Eddie has vanished. Where did Eddie go? Oh. Okay. Chi-Chi?
Yes, ma'am, can you hear me?
Yes, I can.
Ma'am, after I'm getting that answer, we have to punch 3 over 3 on the calculator, and then it'll give us 7. Oh, it's
We're
not.
not using calculators, remember? So remember we have the same base. So what can we do to these exponents?
We have to
It means that they are?
not the same.
They are equal, Chi-Chi. Remember, if 3 to the exponent of x plus 1 is the same as 3 to the exponent of 3, you're basically saying 3 to the exponent of something, we don't know what that something is the same as 3 to the exponent of 3, right?
Yes, ma'am.
So do you agree that x plus 1 has to be equal to 3?
Yes, ma'am, I agree.
There we go. So once you have them in the same base, now it's easy. You just equate the exponents. So our exponents are x plus 1 will be equal to?
X plus 1 will be equal to 1 equal to 1.
What's on the right?
No, x, ma'am, sorry.
Look carefully, Chi-Chi. X plus 1, this is where I'm looking, will be equal to?
3.
3. There we go. And now we solve for x. So how do we solve for x?
Ma'am, we take the x and turn it into a 1.
No, we are getting rid of the 1 that's on the left. How do we get rid of that? We want x to be left on its own, right? So we want to say therefore x equals. How do we get rid of that 1? We transpose. Do you remember to solve for x? When you take it over, it becomes negative, Chi-Chi, so it will be 3 minus 1. And then your final answer is therefore x equals 2. Do you see?
Yes, ma'am.
I think the more you do of these, the better we become.
Okay, ma'am.
There we go. Thank you. See, guys, this is why I wanted to go step by step. We cannot be flying. We need to make sure everyone is with us. How can we be 3 if we still have to plus 1 to get 27? No, we saying that the whole exponent, the whole of x plus 1 is equal to 3. Check this, Owami. We just solved for x, right? We said x is 2. Therefore, if we substitute x, it's going to be 3 to the exponent of 2 plus 1. which is exactly what we had on the right-hand side, because 2 plus 1 is the same as 3. You see that, Owami? So you can solve for x, and then you substitute it back in to check your answer. So x is 2, because if you substitute it back in, you will indeed get the same as the right-hand side. I hope we are keeping up, guys. Okay, there's a nice, interesting one. Lefa, raise your hand so we can talk about it, about where I lost you. If you don't want to, you can pop your question in the chat, and I need someone who's going to help me with number C. Who's going to help me with number C? Zinhle. I saw Zinhle's hand. Oh, Lefa is unmuted. Lefa?
Ma'am, can you please help me with something? I was kind of lost because of the connection.
Okay, where did I lose you?
Here, ma'am, when it says x plus 1 is equals to 3, then the connection was lost.
Okay, did you see how we got there?
Yes.
So we made the bases the same, right?
Yes.
Once your bases are the same, you can make the exponents equal to one another. So the exponent on my left was x plus 1 equals the exponents on your right, which is 3. Okay? Then we want to be left with x on its own on the side. Okay, we want x to be left on its own. And at this moment, it has a plus 1. So do you remember when you solve for x, how do you get rid of that plus 1? You take it to the other side, right?
Yes, ma'am.
Or you transpose it. But what happens when it gets to the other side? If it was positive on this side, it becomes?
It becomes negative, ma'am.
There we go. So it goes to the other side and becomes 3, which was already there. Do you see it? Minus the one that we just put there. That's why your final answer will say, therefore, x equals 2, because 3 minus 1 is 2. You see now?
Yes.
Wonderful.
Thank you, ma'am.
You're welcome. Okay, all the hands vanished while I was talking to Lefa. Come on, guys. Let us solve this one together. Oratile, thank you very much. Hi, Oratile. And then Oratile vanished again. It's fine. I'll do this one. It's okay. We can do this one together. Okay? The small details, Chiki, that is what's going to make you lose the marks. Okay? So we have a base of 4x plus 2 equals. Now, you guys tell me, what base do we want on the right? Tell me which base do we want on the right? Nope. There we go. Okay, the symbol, we do not want 64. Okay, we want to have the same bases on the left and the right. Amasha says 4. What does everybody else say? Wangi? Not what do we have? Listen to the question. Okay, let me fix this then. Wangi, are you there? So we have 4 to the exponent of x plus 2. There's a pen too thick. Let me do this again. Yes, we want the exponent of 4 equals 1 over. Tell me, guys, in the chat, 64 is the same as 4 to the exponent of what? Tell me. So 64 is the same as 4 to the exponent of how much? 4, 3. Thank you, Owami, guys. We need to check our bases. Exactly. So 64 is the same as 4 cubed. Okay. Now the problem is this 1 over. Okay. What's happening there with that 1 over? Which law can we use to make sure that we have same bases on both sides. Think about our laws of exponents. Yes, Chichi. Katu, I'm gonna need you to follow the steps with me, okay? My question was, which law did we use to get 4 to be in our numerator? What are we trying to do here? We're trying to move this up there, right? So that we have base of 4, base of 4. What happens? Law 6, which says what, Chichi? Remind us quickly. Just to make sure we're thinking about the same law. So on this side, we're going to keep our 4 and x plus 2, right? Equals. Negative exponent. Thank you, Amahle. We want the reciprocal, right? At this moment, our exponent is positive, but we don't want it to be in the denominator, right? We want to have 4 on both sides so that our bases look the same. Okay, so if I'm going to move it up, then it's going to acquire a negative exponent. Brilliant, Amahle. Major shout out to you. See? And I know I might have lost some people. Let me know now if you are just like, what just happened? Before we move on, let me check in the chat. Is everyone getting there? Is everyone sort of following what's going on? There we go. Yes, ma'am. Okay, so now we have achieved what we wanted, which was same bases. In this case, I really like pink, if you couldn't tell. In this case, our basis that we really want is 4. Okay, so now what can we do? Now we can equate our exponents. So on the left, we have a x plus 2 equals negative 3. Do you see that, guys? Ma'am, where did you get 1 over 3? It's 1 over 4 to the exponent of 3, okay? We checked, how can we get 4 as a base to equal 64? No, Voyo? I saw you said you are lost, my darling. Where did I lose you?
Ma'am, I don't understand. Ma'am, the third step, how did we get rid of the fraction?
Remember, what did the law of negative exponents say? Remember, if we said if we have 1 to the negative 2, what did we do in this case if we wanted a positive exponent?
Ma'am, you changed it to the positive. You changed it to become positive.
How did we do that?
Ma'am, I'm not sure.
We did the reciprocal. Okay, guys, if you missed the previous lessons, you need to go re-watch them. Make sure you understand, okay? So reciprocal means 1 over a squared. Do you see what we did?
Yes, ma'am.
So in this case, we already had 1 over something squared. Do you see that? Well, cubed in this case.
Yes, ma'am.
But we want the 4 to be in the numerator so that we have 4 on the left and 4 on the right. So basically we're going backwards. Remember, guys, that laws of exponents work backwards as well. Do you see what we did? So we took 1 over 4 cubed and we made it a negative exponent. Do you see that?
Yes, ma'am.
So we went backwards. Do you understand now?
Yes, ma'am.
And then from here on, if we have the same basis, what can we do to the exponents?
Remember, the exponent's negative or positive?
Okay, we leave them as negative. We're not trying to make them positive right now, right? Right now, we have the same base on both sides, which is what we wanted. The one on the left, on the right, excuse me, is negative 3. And on the left, we have x plus 2. So since we have the same basis, what do we do to the exponent?
Let me write it as a fraction form.
Look what I did here. Remember, same basis means equal exponents. So what do? We
must
make the exponents equal.
Yes, ma'am.
Okay, so the exponent on our left was what? What was the exponent on the left?
X plus 2.
So we're going to say x plus 2 equals, exponent on the right is?
-3.
-3. Okay, and now we can solve for x. How are we going to solve for x? We have to get rid of this 2 that's on the side. Do you agree?
Yes, ma'am.
How do we get rid of that?
X is equals to -3 minus 2.
There we go. And that's how much?
-5.
-5. Therefore, x will be equal to -5. Do you see?
Yes, ma'am.
So what we're trying to do is trying to get the same bases on both sides so that we can equate the exponents. All we did here was we went backwards on the law. So we made it a negative exponent so that we can have the same bases on both sides. Are you with me?
Yes, ma'am.
Wonderful. Thank you for asking. I love it.
Thank you, ma'am.
Hey, you're welcome. Hey, guys in the chat. Did we all see what happened there? Yes, Paul. Beautiful. I love it. Thumbs up, thumbs down. How are we doing? How are we doing with exponential equations? Okay, good. Bridget says thumbs up. Mpo says good. Anele, thumbs up. Amashe. I keep forgetting to check reactions. There we go. I knew I would have more. Okay, I have a couple of thumbs up in reactions, so that's good. Okay, let's do some more. Whew. Now it's not so easy, is it? Now it's not so easy, but we can do it. We can do it. Guys, we can do it. Remember, we need to remember first things first is we want what on both sides? We want the same base. Okay, that's first goal. Goal number 1 is same base. What base can we use where we can put 9 and 27 in exponent form? Let me know in the chat, guys. I see a thumbs down. Ask a question so I can help you. Which base can we use? This time it might not be so straightforward, right? So far, we just used the base that was on the other side, but now we have a 9 and a 27. You cannot use a base of 9. Remember, we're working with exponents, guys. 9 squared is definitely not 27. But which base will give us? Very good. Thank you, Amashe. We use a base of 3. Right? There's 2 Amashes. I just got confused for 2 seconds. I was like, what just happened? Okay. Try it. Yes, thank you, Nelly. So try to use prime numbers in most cases. It won't always work because in the previous one we had, yeah. But try to use prime numbers. Okay. If we used prime numbers in the previous one, we could have used a base of 2 and it would still have worked. Okay, I'll call you Amashe G, and then we have another Amashe. Got it. So let us use a base of 3. 9. 9 can be rewritten as 3 to the exponent of what? So this can be rewritten as 3 with an exponent of? Eddie's hand is up. Eddie's going to help me with this. Remember 9, guys. Not 27, 9. Yes, Eddie.
Amendment would be to the power of 9.
To the power of 9.
I'm just joking, Amendment would be to the power of 3.
It's not 3. Check again, Eddie. How do we get from 3 to the power of something to a 9? 9 is the same as 3 times?
3. Yes, it's 3. It's 3 to the power 2.
2. There we go. And then we still had the x minus 3, which was outside. Did you see that? Eddie has vanished. Eddie answers and then vanishes. He's like, goodbye and so long. I've done my part. Okay, Nobuyo.
Doesn't wait for you to let him go, but like, he just answers it and vanishes.
Eddie's like, there you go.
Eddie.
Bye. Thank you, guys. I see you in the chat. Nobuyo, are you going to help me finish the sum off? Nobuyo is also quiet. Nobuyo is like, I don't know if I want to do that. Okay, it's fine. Okay, it's fine. In the chat, guys, let me know. 27, rewrite 27.
Oh, sorry, ma'am. I had problems. I wanted to answer.
There we go. Okay, tell me 27 can be written as 3 to the exponent of? Pumzile is helping me in the chat. And Amasheji and Sunday.
27. 3 to the power of 3.
Hey, there we go. Thank you. See, you never swipe for nothing. Okay, guys, what do we have here? What do we have here? I keep using blue. Maybe it's time to change. Let me use yellow and leave pink alone. Now we have power to a power on both sides. Do you guys see that? What did we say we do with power to a power?
Let me multiply the exponent.
Yes, thank you, Nobuyo. So on this side, you're going to have 3 squared to the power of x minus 3. Okay, this is times, I put brackets, so this is times, equals 3 to the power of 3 multiplied by x plus 1. Okay, so far, are we with me? Are we sort of getting it? I hope we are sort of getting it. Now, guys, at this moment, you have 2 options. You can either already make your exponents equal, or you can first distribute your 2 in your bracket and the 3. Which one do you guys prefer? Must we first distribute, or you first want to make them equal to each other? Because remember, you want to distribute, Nobuyo? Is that what you said? Okay, I think that's what Nobuyo said. Everyone's saying, yes, ma'am. Let's distribute first. This is our distributive law, and of course, my laptop is going to act up. There we go. Distributive law. So we're going to say 2 times x and 2 times negative 3. So 3 to the exponent of, what is 2 times x? Everyone, tell me what 2 times x is. No? Anyone? For a moment, I even thought I was disconnected, guys. You guys just went quiet. 2x, thank you. What's 2 times negative 3? So this will be 2x. And 2 times negative 3 is? Minus 6. Thank you very much. Thank you very much. Guys, you guys are doing beautifully. Equals. Now we are distributing what's on the right-hand side. 3 times x. Yes, guys, I love it. It's 3x, and 3 times 1 is just plus 3. Whew. Great, né? Beautiful. You guys, I hope you guys are actually getting this. And now, what have we achieved? We have achieved same bases. So tell me in the chat, once we have achieved same bases, what can we do to the exponents? We can? Okay, calculate, but first we have to do something to the exponents. No, guys. Same bases, what exponents? We are not multiplying, guys. We cannot add them. Sure, guys, you are all skipping one important step. Can I add exponents when they are on two different sides. We want to get rid of that base. How do we do it? Come on, guys. Oh my goodness. We make them equal. I can't believe you guys are all forgetting this. What's happening? Same base. Add your, make your equations equal. Make your exponents equal. Same base. Make your exponents equal. Again, first one. Same base. Equate your exponents. Sure, you guys, I can't believe this. I can't believe this. Maybe it's time for a brain break, man. Maybe it's time for a brain break, but it's fine. I'll forgive you. Whew, I'll forgive you. So now let's equate our exponents, okay? We have the same basis, so exponents are 2x minus 6 will be equal to 3x plus 3. And now we can do all of those things that you were saying we must do. It's okay, guys. I know it's a lot of information, but you guys are doing well so far. So help me solve for x. How are we going to solve for x? Now we have x's on both sides and we have numbers on both sides, but we don't want that, right? How do we solve for x? Chichi, what's your question? In the meantime, guys, tell me how to solve for x. Nope. That is what I want. You should have said it, Novoyo. Whenever we have a group 2x and 3x, thank you, Amahle. So I'm going to group them on the right. So 2x, this 3x is going to go over. It's going to be minus 3x is equal to, we already had a 3 on the right, and we take our negative 6 over to that side. It becomes plus 6. What is 2x minus 3x? Let me know, guys. See, we're back on track. You guys are just whoop, 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 whoop. We don't replace or take it out. No, leave it there. You just subtract. Be careful. 2x minus 3x is, check, 3x is bigger, so it's not just x, it's how much? It is negative x. Negative x. I'm going to be careful. Okay, and then 6 plus 3 is just how much? 9. Are we done? Are we done solving for x? Be careful before you answer. Are we done solving for x? No, we're not. We need to get rid of the, we need to get rid of the negative. How do we do that? We divide both sides by -1, -1. Therefore, our x is equal to -9. See, you guys are back on track. I knew it. Beautiful, beautiful. Whew, that's a lot, né? Okay, I have a very nice one for us to do, but let's first go to our brain break before you guys explode. Okay, joke for today. Why did the students wear glasses in math class? To improve division. Oh my gosh. That's a very lame joke, but I love it. And coming from someone who wears glasses, I love this joke. Chichi says, ma'am. Yebo, Chichi. It is a long sound, guys. We need to keep up with math. We have to combine all the tactics and tips that you know. You combine BODMAS with those exponents, with algebra, with integers, with all of that. Okay, everyone who has glasses, major shout out, guys. We are improving a division. Okay. Okay, let's work out ourselves for today. Guys, this is our brain break. I'm not sure if this brain break is going to help because we've been struggling with solving for x today, and this is basically solving for x. But I have faith. You guys are really good at these things. So let me know. Okay, Chichi says, oh, just 3. Yo, I missed the last sum. We involved almost all laws, right? I think so, Chichi. We'll check just now. We'll check just now. Has anyone figured this out yet? No. So we have 2 lemons. Ooh, this is getting tricky. Guys, I don't like these. 2 lemons plus a grape times lemon is 120. So how much is lemon? What a difficult, guys. Has anyone figured this out? Let's see. Lemons is 20. Okay, whoever says lemons is 20. So if we have 20 there, we're gonna have 40 over here. Right? So then it's gonna be 120 minus 40, so it's gonna be 80 is equal to something times 20. So grapes is gonna be what, 4? Is that what we're saying? Okay. Are 2 grapes or 1? Oh, that's a good question. No, it's 2 grapes. So does it mean the 2 grapes are 2 each? Katlejo's hand is up. I'm not sure if you have a question, Katlejo. Katlejo, say something, my dear. Okay, Eddie?
Ma'am.
Have you solved this?
So the lemons are 40 and the 2 grapes are only 2 each. So it does give you 180. I mean 120, sorry.
So the grapes are 2 each. So they are 4, but they're 2 each. Okay. So here, the lemons will still be 40, right?
Yeah.
And then the blueberries will be how much? Eddie left again. Eddie, you must stop breaking my heart. Eddie's like, goodbye and so long. I'm done with you. Oh, okay. 40 plus 8, okay, yes. Right, Eddie's like, bye, girl. So if these are 2, and that is 4, that will be 6, right? So it's going to be 53 minus 6, which is 40. Guys, is this adding up? 47. Is this 47, guys? Can this be 47? My brain is just like, hey, what a difficult. And then I need someone to tell me what all these things are because my brain is confusing.
Yeah, it means that the blueberries will be 47 because it's a plus and a plus.
Okay.
And then 40 times 47, it won't work.
Exactly.
The previous one.
You see the problem here, guys?
Yeah. Maybe the lemons aren't 40. Oof. The math is not messing. Okay.
I get guys. Guys, 23. 23. What's 23? Ooh, Eddie's freaking out. Eddie's like 23. Oh, I'm gonna explode.
What's 23?
Shoo. Hi guys, this is too much. Take a screenshot. I am challenging you guys to bring me the answer in the next lesson. This is where we're gonna start, okay? Because I want us to do our last sum before we leave, and I have to leave soon. So, okay, let's leave it. Okay, you guys can go and do it. You can rewatch this lesson and do it on your own and come with an answer next time. Now, what's happening here? We still want the same base. Eh? Oh. I'm telling you, you'll have to rewatch the lesson on Sunday. We're running out of time. Okay, I'm telling you that we want a base of 5. How can we make that happen if we have a 1 on the right? Somebody give me a solution. So we're keeping the base of 5 plus 3. So we want to rewrite the right-hand side as 5 to the exponent of something, but that something needs to give us an answer of 1 ultimately. What will that something be? No. Definitely not. 5 to the exponent of what is 1, guys? Think about your rules. Think about your laws. This is a trick question that we love. 0. Okay, so if you have a 1 on any side, you can make it a 0. And now we have achieved what we wanted. Same basis equates the exponent. So x plus 3 will be equal to 0. We transpose the 3, therefore x will be -3. Ooh.